When chemicals react, they form bonds. These bonds are formed between the electrons of each of the elements that are involved in the bond. Now, when you write a chemical formula on paper, you really don't get to know what the shape, the structure of that molecule is. And this can give you a wealth of information to actually figure out why certain molecules react the way they do or interact with their surroundings the way they do. Now, in order to actually really understand the elements, you need to know how many electrons are actually the valence electrons, so the outer shell of the electrons there are. So looking at the periodic table, group 1A, group 2A, group 3A, group 4A, group 5A, group 6A, group 7A, and group 8. Each of these has, so group 1A has one electron, group 2A, 2, so far over to group 8A, which is the noble gases. So we illustrated this using, it's called Lewis dot structures. So group 1A has 1 dot, group 2A, 2 dots, 3 dots, 4 dots. Once you get to 5, you then start pairing up. The reason why we haven't paired up electrons until now is because the electrons they're alike. They don't want to be next to each other. They want to be as far apart as possible. So after 4 electrons, you start doing lone pairs. So 2 lone pairs, 3 lone pairs, and then finally a noble gas is 4. Now, in order to form, for instance, carbon to be stable, form a stable compound, it wants a configuration like a noble gas. It wants 8 electrons around it. Now, lithium, for instance, it would like to give up that electron, and it doesn't really need electrons around it. Using this, we can actually build what the molecules theoretically should look like, and if they have a double or even triple bond. So let's try it out. We have 2 compounds, water and carbon dioxide. So water has 8 electrons. 2 electrons from the hydrogen, 6 electrons from the oxygen. Write it out, forming a bond. So these are 2 electrons of the 8. Also is the electron from each of the hydrogen atoms. So we have 4 electrons left. So they could be, in order to complete the octet on the oxygen, we add 2 lone pairs. Now this is a stable molecule. Now carbon dioxide, drawing it out, has 16 electrons. So putting a bond into it, so 4 electrons are into the bond, so we have 12 left over. However, you see when you map them all out on the oxygen and the carbon, there's a single electron on both oxygens and 2 of the carbon. How to correct this is by actually making a double bond between those. So carbon dioxide now has 2 double bonds. So this has a linear shape, while this actually has a bent sort of shape. Now, for practice, write out the Lewis dot of nitrogen and phosphorus trichloride. And we'll go through it when we come back. All right, let's start off with nitrogen. Nitrogen has 10 electrons. So putting 1 bond between it and then trying to fill out as many, you fill them out. So 1, 2, 3, 4, 5, 6, 7, 8. But the octet's not satisfied for either one. However, if we take these 2 single bonds and make bonds with them into a triple bond, we now have a stable molecule. We have 8 on each atom. It's a stable molecule. Phosphorus trichloride, 26 electrons. Drawing out, so 2, 4, 6. 6 of those electrons are already taken up. Filling out the chlorines. So 2, 4, 6, 8, 10, 12, 14, 16, 18. 18, so we only have 2 electrons more. By putting a lone pair on phosphorus, that's eliminated. So now we have the Lewis, complete Lewis structure of nitrogen and phosphorus trichloride.